All right, today we're putting on our detective hats. We're going to solve one of the most common and, frankly, most annoying mysteries in any modern office, the case of the disconnected PC.
You know the feeling, right? We've all been there. You click on your browser, you're ready to get to work, and nothing. It's just dead. It's super frustrating, and it can feel like you're searching for a needle in a digital haystack. But what if I told you there's a logical method to all this madness?
So to really learn the method, we're going to walk through a real-world scenario. Let's go ahead and open the case file on this disconnected PC.
Here's the situation. We've got a report from the folks at a company called TechLink Solutions. A user is having a problem with a machine they call PC2. It's completely cut off. No internet, can't talk to its neighbors, nothing. Our job is to figure out what's going on.
Okay, so before we can find what's wrong, we gotta know what right looks like. This right here is our blueprint. Think of it this way. The IP address is like a house number. The subnet mask defines the neighborhood. And the default gateway, that's the main road out of the neighborhood to the rest of the world. The key rule is everyone needs to be in the same neighborhood, which, in this case, is 192.168.20.
All right, with our blueprints in hand, we can finally start our investigation. It's time to line up the suspects and figure out what could be responsible for this mess.
So, this is the big question, isn't it? What are the potential culprits here? You know, a network connection seems pretty simple on the surface, but there are a few key points of failure we absolutely need to investigate. And here they are, our list of usual suspects. It could be something really simple, like a loose cable. Or maybe it's a software issue, like a firewall that's gone rogue. Or, and this is a big one, it could just be that the computer has the wrong digital address entirely.
Now, to interrogate these suspects properly, we're going to need the right tools for the job. And the good news is, they're built into pretty much every computer out there. So, welcome to the Detective's Digital Toolkit.
And this really gets at a key idea in troubleshooting. The most effective tools are not always the most complicated ones. Seriously, a couple of simple commands can tell us almost everything we need to know.
Our first tool is ping. Think of it like shouting, "Hey, are you there?" across the network. You ping another device's address, and if it answers back, you know there's a live connection. It's basically a digital game of Marco Polo. Our second must-have tool is ipconfig. This command is like asking the computer, "Hey, let me see your ID card." It tells you exactly what address it's using, what network it thinks it's on, and where it's trying to go to get online. This is how we check if a computer's ID actually matches our blueprint.
Okay, so we've got our suspects and we've got our tools. It's time to get to work and systematically track down our culprit. This whole thing is about following the clues in a logical order. You know, any good detective is methodical. We always start with the simplest explanation and work our way up. So first, you check the physical stuff. Is it even plugged in? Then we use ipconfig to check its ID. This approach, moving from the physical cables to the logical addresses, well, that's the heart of professional network troubleshooting. Only after that do we start pinging, first to see if it can talk to its neighbors, and then, finally, if it can reach the router.
So let's fast forward a little bit. We've done step one. The physical cables are fine. We see the little lights blinking on the network card. This tells us our problem is invisible. It's a logical issue. Now it's time to crack the code.
So we sit down at the silent PC2. We open up that command prompt and we type in that one crucial command, ipconfig. We hit enter and the computer shows us its digital ID card. This is the moment of truth.
And there it is, the smoking gun. This is the output we get from PC2. At first glance, yeah, it's just a bunch of numbers. But hidden right there, in plain sight, is the one clue that solves this entire mystery. Take a second. Do you see it?
Now, let's put that clue right next to our network blueprint. Look at that. PC2 thinks its network is 192.168.1, but everybody else in the office is on network 192.168.20. That single number, that 1 where a 20 should be, that's the source of all our problems.
It's so simple when you see it. PC2 has the wrong address. It's like it's trying to talk to its neighbors on Elm Street, but the rest of the town lives on Oak Street. No matter how loud it shouts, nobody can hear it, and it can't hear anyone else. It's just fundamentally lost.
And the fix then is beautifully simple. We just go into PC2's network settings and manually correct its ID card to match the office blueprint. We change the IP address and the gateway to the correct 20 network, and boom, just like that, communication is restored.
So, with the right address, PC2 is back online and our user is happy again.
case closed. But, a great detective doesn't just solve the current crime, they try to prevent the next one. So let's look at how we can stop these mysteries from ever happening again.
Yeah, we solved the immediate problem, but let's be real. This was probably caused by human error. Someone just typed in the wrong number. So how can we make the whole system more robust so that a simple typo can't take a whole computer offline?
Here are 4 essential preventative measures. Now, the most important one by far is using something called DHCP. Think of it like an automatic address librarian for your network. It just hands out the correct address to every device automatically, so nobody ever has to type it in by hand. This is the industry standard for a reason. It completely eliminates this exact kind of human error. The other tips, good documentation, clear labels, regular checkups, they're all part of running a clean, professional, and mystery-free network.
And that's it. We went from a totally disconnected PC to a solved case, all just by following a logical process and using a couple of simple tools. This method, starting with the physical, moving to the logical, it can help you solve almost any network issue you come across. So the real question is, now that you know how to think like a network detective, what mystery are you going to solve next?